In this video, we're going to talk about inverse functions. We're going to start with the horizontal line test. Okay, so recall we used the vertical line test to determine if a graph was a function. Okay, so that means every x has only one y. Now, if you have an inverse, that also means you switch the x and the y. So that means every y has to also have only one x, and that's called a one-to-one function. Okay, so if a function basically has every x has one y. If it's able to be an inverse function or a one-to-one function, then every y must also only have one x. So we use the horizontal line test, and it has to intersect the graph once. Okay, so if it intersects the graph once, the graph passes the horizontal line test and is a one-to-one function, which means that it has an inverse. Oops, there's an R in there. Okay, so it has an inverse. All right, so let's check these functions here, and let's see if these functions are one-to-one. If they're one-to-one, then they're able to have an inverse. Okay, so first of all, is it a function? Okay, so if you look up and down and graph these vertical line tests, then if every time you hit the graph you only hit it once, then you are a function. Now, if you go the other direction with a horizontal line test, and you can draw horizontal lines and only hit the graph once, then it is a one-to-one function. Okay, so there's no place where I can draw a horizontal line where I hit the graph more than once. So is this one-to-one? Yes, it is. Okay. Okay, so the next one passes the vertical line test. Even here, it passes the vertical line test because this is an open dot, closed dot. So the function only exists here. But if you draw lines here, like you could draw a line right here and hit the graph twice. So that one does not pass the horizontal line test. So it is not a one-to-one function. Okay. This one, again, passes the vertical line test. If we look this direction, only hits once, only hits once, 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 once. So yes, this passes. There's no horizontal line that you can draw that'll hit two dots at the same time. Okay. This one down here passes the vertical line test, so it is a function. But it fails the horizontal line test because you can draw a line anywhere down here and hit the graph more than once. So this is not one-to-one. Okay, this one passes the vertical line test, but does it pass the horizontal line test? Can you draw a line going left to right and hit the graph more than once? And it looks like you cannot. So this is a one-to-one function. Okay, and the last one. Draw straight up and down, vertical line test, it passes. But if you draw a line right here, you hit the graph twice. So this is not a one-to-one function and not able to have an inverse. Okay. Let's look at a few more. Okay. Assuming that all these are functions, we're only going to now look at the horizontal line test. This one you can draw a horizontal line and hit twice, so that's a no. Here you can hit twice, so that's a no. You can't hit twice if you go horizontally here, so that's a yes. You can hit twice here, so that's a no. You cannot hit twice going this direction on this one, so that's a yes. And you cannot hit twice going this direction, so that is a yes. Okay, so that's the horizontal line test. Now let's talk a little more about inverse functions. If you are an inverse function, you can compose one function within the other. So f of g of x, so put the g of x inside the f function. It's going to give you x, which is the same thing if you compose them the other way, if you put f inside of g. Okay, so this is a proof. If you're given two functions and you're asked, are these two function inverses? Well, compose them both directions and both answers should give you x. Okay, so looking at this one, if we take f of g of x, okay, that means g is going to go in place of x. So everywhere in this that I have an x, I'm instead going to put an x minus 3. So it's going to be x minus 3 plus 3. And the minus 3 and the plus 3 cancel out. You get x. So that works. that gives us x. And if you do the other way, g of f of x, put the f of x function into x right here, in place of x in g, okay, that will be x plus 3 minus 3, which also gives you x. So these two are inverses of one another. Okay, let's look at this one. So it says we have 2 over, f of x is equal to 2 over x so long as x is not equal to 0, and it's equal to negative 2 over x so long as x is not equal to 0. Okay, so let's see what happens when I compose f of g of x. Okay, so I put the g function, negative 2 over x, into x here. So I get 2 over negative 2 over x. Okay, now this should already be setting off some sort of alarms in your head, because it's going to be negative, right? And it says they must be equal to x. And this whole thing is going to be negative, so that's definitely not going to work. It's going to give us a negative x. But let's go ahead and flip the bottom and multiply. So 2 over 1, that's the top, times x over negative 2. That gives us negative x. Okay, so f of g of x is equal to negative x. So that's automatically, everything else is going to fail. But let's go ahead and figure out the other way. So we found f of g of x is equal to negative x. Let's plug in the other way. G of f of x is equal to, okay, so we're going to take the 2 over x and put it right here in place of g. The 2 over, let's see, that's a negative 2 over 2 over x. Okay, so again, you flip the bottom one up, you multiply, and you'll get negative x. So they got the same answer, but they're both negative x. So these are not inverses of one another. You have to get x as an answer. Okay. All right, let's take a look at this one. So if I compose f of g of x in here, so that means I'm putting the g function, 2x plus 1, in right here. So instead of x minus 1 over 2, I'll put 2x plus 1 minus 1 over 2. Okay, so that's going to give me, the 1 and the negative 1 cancel, so 2x over 2 equals x. So that one works. Let's go the other way. G of f of x. Okay, so that means we're going to take this and put it right here in place of that. Okay, so instead of 2x plus 1, it's going to be 2 times x minus 1 over 2 plus 1. The 2's cancel here, so you get x minus 1 plus 1, which is equal to x. So it works. Okay, these are inverses of one another. All right, last one. So we've got 2x plus 3, f of x, and then you got x minus 3 for g of x. Okay, so let's do f of g of x. Okay, so we're going to put all this stuff right here in place of x. So instead of 2x plus 3, it's going to be 2 times x minus 3 over 2 plus 3. The 2's cancel. X minus 3 plus 3 gives you x. So that works. Let's go the other way. So we'll take the 2x plus 3 and put it right here in place of x. So instead of x minus 3 over 2, well, first of all, let me write this. Okay, so instead of x minus 3 over 2, we're going to put 2x plus 3 minus 3 over 2. The minus 3 and the plus 3 cancel, so we get 2x over 2 equals x. That works, and they are inverses of one another.